Hello! Now we're doing another polynomial inequality, and we aspire to find a solution set for this rational equation. Take a look. This is a ratio of two different polynomials. The ratio of the polynomial 2x divided by x plus 1. Just like we've been doing, we want to treat this like an equation, analyze the inputs on a number line, and see if the outputs result in a contradiction or in a true statement. So let's do it. We'll treat it like equality. Okay? Then, moving on, I'll subtract the 1, so I get 2x all over x plus 1 minus 1 is equal to 0. Bring this up here. I give them a common denominator, multiply top and bottom here by fancy number 1, this x plus 1. And put it all over x plus 1. I multiplied negative 1, top and bottom, by x plus 1. So I just get x plus 1 all over x plus 1 with the negative in the numerator. And so I could just divide the whole thing by x plus 1 under one big division bar. And now we have this. And so I distribute that negative, so I get 2x minus 1 all over x plus 1. I then can rewrite this as x minus 1 all over x plus 1, and recall it was equal to 0. So this is what we want to analyze. This rational function, when is it equivalent to 0? We know whenever a rational function is equivalent to 0 is whenever the numerator is equal to 0. So we set x minus 1 equal to 0 and solve for positive 1. This is when it equals 0. X equals 0 at x equals 1. But notice, since we're dividing by values of x here, there's going to be points in which the function is undefined. And that's when the denominator is 0. So we'll set the denominator equal to 0 and solve for that x value, and that's negative 1. So this is when x is undefined. It's undefined, the output of the function. It's not necessarily x is undefined, it's really f of x is undefined. Okay? Now, we analyze this in terms of the number line. We create a number line here. We put a reference point 0. We put our important players 1 and negative 1. We know that for the value of x is equal to 1, that it satisfies the equation. So we want to pick that value. But what about to the right of it? Let's say 2. What about values to the right? What about values in the middle? And what about values to the left? We'll pick some value to the right, say 2. Okay? So when we pick 2, we'll have, in terms of this equation, 2 minus 1 divided by 2 plus 1. Is this equal to 0? Well, or is it greater than or equal to 0? Notice that will result in 1 over 3, which is greater than or equal to 0, so that works. So these values are okay. Now let's analyze values in the middle. Let's say 0. So let's see if 2 or 0, we're replacing 0 for every x here in this one. So 0 minus 1 divided by 0 plus 1, this results in a negative 1 over 1, which is a negative 1. Is this greater than or equal to 0? No. It isn't. So we don't take these values here. Okay? It doesn't work. But what about some value to the left of negative 1? Let's say negative 2. Will it work? Well, we go over here and we look at negative 2 minus 1 divided by a negative 2 plus 1. I get a negative 3 all over negative 1, which gives me a positive 3. And this is greater than or equal to 0, so that works. So these values work. However, we must recall that at negative 1, we're dividing by 0. So this point is undefined. So although it works, we want to put a parenthesis here, not a bracket. And over here at 1, we do want to put a bracket because it can equal 0. But it can't be anything more than it, if that makes sense, because we can replace this here, greater than or equal to 0, and at the value, x is equal to 1, it does equal 0. So over here we will put a bracket, and we'll highlight all these values. And so our solution set will be negative infinity all the way to R1, but we won't include it because that's where we're dividing by 0, union, the bracket, 1, all the way to positive infinity. Now, as you can tell, these problems require you to think thoroughly about this. Treat it as an equation, find the points of interest, put them on the number line, plug those values back in to see if there's a contradiction or not. If there is not a contradiction, those are part of the solution set. If there is a contradiction, then those won't be part of the solution set. And whenever you're dividing by values, make sure to exclude values that will cause you to divide by 0.